Hello chemistry students, this is now the second revision video before we start our module 1 content. Here we're going to be talking about elements, compounds, and also writing up chemical formulae for these particular kinds of substances. Now first off, I want to look at an element. Now an element by definition is made up of one type of atom, but in particular what I'd like to share with you is that we can see that there are many different versions of elements. This helium atom here is only made of one atom. It's an element because it's only made of helium, whereas things like hydrogen and oxygen and chlorine here are all made of two atoms, but they're only made of the one type. This hydrogen molecule is only made of hydrogen atoms, the oxygen is only made of oxygen atoms, and the chlorine is only made of chlorine atoms. Now these are molecules because they have more than one atom, but elements because this molecule is only made of one type of atom. Now we can also have elements that have more than two atoms. For example, this molecule here is ozone. It's only made of oxygen. It's still an element, but it's made of 3 oxygen molecules. And this sulfur molecule here, S8, it has 8 sulfur atoms to make one single molecule. Now, all of these elements are sorted into the periodic table of elements. Now, this is something that we're going to be looking at over and over and over again throughout the entire course. It is a document that we must become familiar with. Now, we will have plenty of opportunity to do that as we look at how to use the table in many different ways. But for the moment, what I want to focus on is the idea that these elements are all here. They're all sorted into the periodic table, and they're sorted and categorized in different positions because I have lots and lots of different properties, but that's a topic that we'll be covering later on in the module. Now, in particular, what I'd like to focus on is a single square that exists in a periodic table. Now, first off, this atomic number here. This is the number of the element and tells us exactly how many protons are in the atom of the element. So, for example, hydrogen has the number 1, which means that there is one proton in its nucleus. Now, if we were to go back and maybe say look at carbon, it might be a little bit difficult to see, but its atomic number is 6 up the top, which means that it has 6 protons inside the nucleus of every single carbon atom. Now, we can go all the way up to 118. So this guy here, right at the bottom of the periodic table, is the largest element that we know of or that we've produced. It has 118 protons in it, and that is considerable. That is a lot. Next, we have the element symbol. Every single element has a different symbol. Hydrogen just has the letter H. Some have 2 letters, a capital letter and a lowercase letter. Underneath, we have the name of the element, and then the atomic weight is an indication of how heavy the atom is and can be roughly defined as the count of protons and neutrons. It's a little bit more complicated than that. There is a reason why all of them have a decimal place, but that's a concept, again, that we will look at in the future. But it does have to do with its number of protons and neutrons in particular. Now next, I just wanted to show you a bunch of elements that exist as gases at room temperature, and most of these are gases. There might be 1 or 2 that are liquids, bromine in particular. But what we say that these are all diatomic elements. Now they're all elements because each molecule that we can see here, the hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, they are all one single element, but they are diatomic, di meaning 2. And atomic meaning atom, so 2 atomed elements. All of these molecules are, and for most of these are gases. So commonly you'll hear that most diatomic elements or diatomic molecules exist as gases at room temperature. Bromine being the exception, which is a liquid. Next, I have some compounds. Now, these are always molecules. They're always made of 2 or more atoms, but in particular, compounds, unlike elements, are made of 2 or more elements. Now, water is made of hydrogen and oxygen. It's got the formula here, H2O. We'll get back to that in a minute. Methane is made of carbon and hydrogen. So 1 carbon and 4 hydrogens, formula CH4. Now, last thing that I want to look at is the chemical formula and how to write it. Now, for an oxygen molecule, it's made of 2 oxygen atoms. These are both color-coded as red in all of these diagrams. The formula that we would write is O2. Little 2 down the bottom, meaning that there are 2 oxygen molecules. 2 oxygen atoms in the molecule. The other one here, our water molecule, again, this red one is oxygen, and these blue ones here are hydrogen in these diagrams. A lot of the time, you'll find that they're white in color, but this diagram is just a little bit different. Now, we write this one as H2O, meaning that we have 2 hydrogens and 1 oxygen. Now, you'll note as well that I didn't put O1. It's similar to how when we write pronumerals in algebra, we don't put a 1 in front of our pronumeral. Same thing here. If there's only one type of, there's one atom in the molecule that's a particular element, we don't have to put the 1 there. Now, sugar is made of black carbon atoms. These red ones are oxygen again, and these blue ones are hydrogen. Now, this has C for carbon, H for hydrogen, and O for oxygen. But what we have to do as well is count up how many each of each element there are in the molecule. So for carbon, if we count them up, 1, 2, 3, 4, 5, 6. So the formula starts with C6. The H comes afterwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I have 12 blue hydrogens in my diagram. And for the oxygen, the red ones, 1, 2, 3, 4, 5, and 6. So the final chemical formula for this one is C6H12O6. Now the thing to keep in mind, and where people may end up slipping up a little bit, is that the number on, or the number in subscript that's a little bit lower on the left always tells you how many atoms of the element that's been written on the right. Maybe the best example is here with this water molecule. There are not 2 oxygens, but rather H2 means that there are 2 hydrogens. Now, thank you very much, everybody. I hope that this helped you to remember some of the things that you might have done in previous years, and I'll catch you on the next revision video.